All right, welcome to the replay, and for those of you joining live, welcome. Hello Snowboard, hello AV Exec. I'm about to show you a pretty cool demonstration with light. We're gonna look at what happens if I mix colored lights. What happens if I mix red plus blue, blue plus green, and red plus green. Hey King, John, Washer, Jose, or Paige. Hey Doc, welcome. Let me turn this camera around and just say a quick hello before I start the demonstration. Okay, welcome. So my name is Joe McCullough. I'm the physics program chair. Show the ocean, not today. Physics program chair at Cabrillo College in Santa Cruz, California, and I made a commitment to get on Periscope every single day for a year and share daily doses of dopamine through education, entertainment, and inspiration. Hey, all luck, welcome. Good to see you again. Today, I'm going to show you a pretty neat physics demonstration about light and what happens when we mix colored lights. Where can I buy dopamine? Well, if you find out, please let me know. All right, so I'm going to turn this camera around and show you the demonstration. What I have on the whiteboard is 3 different colored lights. And let me just show you the setup we're using because it's pretty cool. So what we have here is a overhead or a projector. We're using a projector because it projects very bright light. And what we did is we took one of the slides and made red, green, and blue filters so that the light coming out is either red, green, or blue. Let me walk this around for 1 second. And then what we created is 3 different mirrors that are going to reflect red, green, and blue onto the board. And then by rotating the mirrors and adjusting the height, I can easily combine the 3 different colors. So I'm going to turn this around. Welcome. What I'm going to show you in a second is mixing colored lights and what happens if I mix red plus green, blue plus green, and red plus blue. And then what happens if I mix all 3. So first I'm going to mix red plus green. Does anybody know what happens when I add red light and green light, what the result is? Anybody want to take a guess before I actually show you? Guesses going once, going twice. All right, here we go. Chris Pin 05, welcome. I'm about to show you what happens when we mix purple light. Good guess. All right, here we go. Red plus green. And what I get when we mix red plus green is yellow. So just give you a quick little demo. Well, I'll give you the explanation here at the end. So red plus green equals yellow. Welcome the revolution. How about red plus blue? What do you think I get when I add red plus blue? Hi, welcome to the broadcast. Today we're doing a little bit of cool color physics. Purple, purple, purple. Let us see. Red plus blue. And the answer is magenta, which is basically purple. So far we have seen red plus, whoops, bring that back. Red plus green equals yellow. Blue plus red, red plus blue equals magenta. And then the very last one we'll look at is blue plus green. Hey Ruben, welcome. Anybody have a guess? And the answer is not purple. What do you think I get when I mix blue plus green? Light blue, great guess. Light blue, let's take a look. And survey says, what do we have there? It is a light blue, it's actually cyan. So blue plus green light mixed together equals cyan. And then let's look at each one again, and then I'll show you mixing all 3 together. So one last time we had green plus red. Red plus green gives us yellow. Blue plus green gives us cyan. And then red plus blue, magenta. Exactly. So a later scope, if you ever buy ink, what do you buy? You buy 4 different kinds of ink. You buy yellow, magenta, cyan, and then black. And then some printers have 2 different kinds of black. Those colors are called the primary subtractive colors. Red, green, and blue are the primary additive colors. So let me mix all 3 together and then check that out. That's pretty cool. Let me see if I can zoom in on this. So where you see red and green overlapping, you'll have yellow. Where you see blue and green overlapping, you have cyan. Where you see red and blue overlapping, you have magenta. And where you see all three overlapping, you have white. Red plus green plus blue is white. Let me turn this around, explain what. So if you've ever taken a look at your computer monitor, and this is something pretty cool, if you have a good magnifying glass, take a look at your computer monitor, and what you'll see is that your computer only has 3 different colors of pixels: red, green, and blue. And you can produce any color that you can imagine by adding red plus green plus blue in different amounts. When I add all 3 together, I get white. So I'll turn this around and show you one more time. All right, so what you're seeing on the board is a mixture of colors where I've added red and green and blue together. And what you're seeing is the combination of colors. Red plus green is yellow, blue plus green is cyan, red plus blue is magenta. And at a later time, I will explain to you the physics behind what's going on. Actually, I'll touch on it right now real quick while we have it. So inside your eye, you have different kinds of photoreceptors. And you've got some that are sensitive to light, and those are called cones. Some that are sensitive to lightness and darkness, but really sensitive to motion, called rods. We have 3 different kinds of cones corresponding to high frequencies, sort of blues, indigo, violet. Middle frequencies are greens, and then low frequencies, red, orange, yellow. And what happens is, let me show you this. Kind of going through what's happening, and I'm going to go to the board I won't be able to see. So hopefully this turns out well and you can see it. So what's happening here is, this is a white board. White reflects all frequencies of light. So where the blue light here is hitting the whiteboard, it's reflecting blue light back to you. When that blue light enters your eye, it causes your cones to fire a signal. You see blue. Up here, green light is hitting the whiteboard, reflecting back to your eye. Again, it causes those cones that are sensitive to mid frequencies to fire a signal. You see green. Up here, you've got the whiteboard. It's reflecting red light back to your eye. Red is low frequency, causing your low frequency cones to fire a signal. You see red. Now what's happening right here is I've got blue light shining on the whiteboard reflecting back, red light shining on the whiteboard reflecting back, and when both of those kinds of cones are stimulated equally, that's when we see magenta. And then in the middle, what's happening is you've got blue light reflecting back, yellow light reflecting back, red light reflecting back. And when all 3 hit our cones at the same time, we see white when red, green, and blue are stimulated equally. So I'm going to turn around, see if there's any quick questions, and if not, that'll be it for today's scope. All right, turning this around. All right, if you're just joining, colorblind people are missing cones and rods. So there's different reasons that people are colorblind. It doesn't have to do with the rods, it has to do with the cones. It could be that certain types of cones are not functioning well, but it also could be other things going on with the brain. Any other questions that I can answer? Let me give you a little preview. I think I'm going to start doing a weekly series called Ask a Physicist Anything. I have an adjunct here who's just brilliant. I think he's one of the best explainers. What's the physics in specific colors? So let me just say that you only have 3 kinds of rods. I'm sorry, 3 kinds of cones. They're sensitive to low frequencies, red, orange, yellow, middle frequencies, greenish, higher frequencies, blues, and violets. And when those 3 cones are stimulated with different intensities, then we see different colors. And your computer monitor only has 3 pixels, red, green, and blue, and it can produce every single color that you see by combining different intensities of red, green, and blue. Do you teach physics? Yes, I'm the physics program chair at Cabrillo College in Santa Cruz, California, and I've been teaching college physics for about 15 years. About to sign off, but let me just tell you that I'm on Periscope every single day. I made a 1-year commitment to broadcast daily and share daily doses of dopamine through education, entertainment, and inspiration. Today was all about education, teaching you some cool physics. If you like that kind of thing, please follow me by swiping from left to right on an iPhone, straight up on an Android. Share this with anybody you like. And also, I archive all of these on my YouTube channel. Just search YouTube for Dr. Joe McCullough. Thanks, Doc. You are so welcome. All luck. All luck, I've seen you here before. What is your name? So I don't have to keep calling you All Luck. I'd love to know your name. Okay, well, I'm going to sign out. Check in tomorrow. Corey, I will remember that. Corey, thank you so much. I see you here a lot. So tomorrow I'll probably show you another physics demo, and then I'm going to start a series. I'm not exactly sure what it is yet. Probably something to do with the brain. I'm thinking about going through Dr. John Medina's awesome book, Brain Rules, and then touching on some of the important brain rules and how you can use that to learn anything faster. So again, my name is Joe. I'm the physics program chair at Cabrillo College, and I'm also best-selling author of Accelerated Learning Techniques for Students. Checking out for today. Have a wonderful, what's today? Wednesday. Have a wonderful Wednesday. Yes, love me some brain stuff. That is my passion. A lot of the scopes in the future, once school slows down a bit, I'm going to be dealing with the brain, how people learn, process, and store information, and how I can use that to learn anything faster. And then for teachers, I'm going to be sharing some cool scopes about how I use brain-based teaching in my classroom to make sure my students really get this information. Can't wait, Kay. I'm excited for you. I'm excited for me. I love the brain. I love physics, and it's going to be an awesome year. This is I believe, day 35 in a row. Woohoo! Okay, that is it for today. Thank you for all of you watching. My name is Joe, and I will see you tomorrow.